So good afternoon, everyone. So I'm Michael McTavish. I'm a Mitacs Elevate postdoctoral fellow. I'm at the University of Toronto, and I'm working with Ducks Unlimited Canada as well. So I'm going to be presenting on behalf of some colleagues and myself here, providing a bit of an update on the biological control program for introduced Phragmites that's happening in southern Ontario. So if you've seen us present on this before, some of the initial material is going to be a little similar. And then we're going to get into some new material from this year towards the back half there, so stay tuned. So as we've been hearing about today, of course, there are many different options for control of Phragmites, and depending on the context, these can really, they can work quite well, or they can vary a lot in their efficacy, affordability, and feasibility. So with something that is as big a challenge as this, what we're really looking for all the time is we have this critical need for additional options to supplement the tools that we already have. So the tool that we're working on is biological control, and we talk about this as trying to bring another option to the toolbox. So not trying to replace anything, just putting another option there for these different contexts that can occur. Biological control, or just biocontrol, refers broadly to the use of live organisms to suppress and introduce pests. There are other forms of sort of bio-related technologies, and we're going to be hearing a little bit about that later through Kirk Kowalski, so stay tuned for that. But what we're talking about right here and why we do this, it's really about reuniting a pet with different forms of natural enemies to try and manage the population of whatever the pest is. Because these natural enemies are highly specific to their host, they are selected for that, they tend to have a very low environmental impact off target. It's a self-sustaining tool once it gets going, as organisms reproduce and track the host through both space and time. And for that reason, it can become very cost-effective, especially at very large scales. So Biocontrol of introduced Phragmites uses two different species. These are European moths shown here. They're fairly drab, brown-looking moths, so Archanara neurica and Lenisa geminipuncta. And it's actually their larvae that do the substantive damage to the plant. So they have stem-boring larvae that will mine the shoots of Phragmites and cause stem wilt and mortality, thereby reducing the overall size and vigor of the population over time. The general life cycle of these two species are a little bit different, but fairly close. Sort of a general look on this. The larvae, which are again the life stage that actually do the damage, they hatch in the spring, and they'll feed in the shoots for a period of about 4 to 6 weeks. They pupate within the stems themselves, and then will emerge and fly for a short period of time as adult moths and mate. And then females will lay approximately 150 eggs under the very close-fitting leaf sheaths of the plant. So they're protected there, they will overwinter there, and then hatch the following spring. Biocontrol programs take quite a bit of time to get underway. The Phragmites program is no exception. This has been in development for over 20 years. So the initial proposals and explorations for insects go back to 1998. By 2005, the process of host agent selection was in process. And then beginning in 2007, there was a very extensive period of host range testing for these species. So this is ensuring that they are highly specific to the target weed and aren't going to be damaging anything else. This culminated in a petition to release these organisms in Canada and the US in 2019. This petition was approved in Canada by the Canadian Food Inspection Agency in 2019, and that then brings us to our current day Ontario pilot program. So what I want to provide now is a bit of a research update on the progress of this from 2019, which is incidentally also when I became involved with the project, to the present day. So this Ontario pilot program, which is the first and only program so far, is based on 3 main objectives. The first has been looking at background monitoring of Phragmites, so this would be both the native and introduced subspecies, to make sure we understand the context that they're working in. The second has been arguably the most substantive, is to develop the core methods for rearing, releasing, and monitoring insects on the landscape. And then finally, to establish insect nurse sites. So these would be locations where insects have created a fairly stable population, they're reproducing, and that can be a source of insects that we can go and collect from in the future. So we'll take a bit of a timeline look at the work that's happened so far fairly quickly here. So back in 2019, again, focusing on that monitoring objective, we began all this with a background survey of native and introduced Phragmites populations across a gradient in southern Ontario. So we sampled a bunch of sites and were able to identify potential locations for quick release and also learn more about the properties of and how to accurately identify and discriminate between native and introduced subspecies here in the very regionally specific area of southern Ontario. So we're also working on a guide for that we're hoping will be coming out sometime in this spring or shortly thereafter. So keep eyes open for that as well. 2020 was when we did really sort of the first releases that I was involved with. One of the big questions is often which life stage you release as. So in this case, you could release as eggs, as larvae, as pupae, versus adult moths, and all of these have various trade-offs to them. In 2020, we released as eggs at 2 different sites. Our first attempt at this shown on the left is essentially to glue the eggs to cards and put them out attached to the stems to try and emulate the natural egg-laying behavior. We learned fairly quickly that this leaves the eggs quite exposed to predation. So at a second site, we developed a method that was very successful at protecting those eggs. In the end, we didn't really end up getting any establishment from this because of the timing with how the eggs were put out, but we learned quite a bit about predation and how to guard against that. This past year, 2021, despite pandemic restrictions, has been a really busy and successful year for us in many ways, and we were able to focus on putting out a good number of insects in different ways. One of the places that we started was looking at overwintering. So when you have eggs, you need to store them until the next year. And so we were looking at how different overwintering storage conditions affects how much hatch you're going to get from that in the spring. One of our 2 species were able to rear on an artificial diet. You can see that in the middle left there. So we had a number of eggs that we worked with in the lab to try and rear through to produce pupae and moths that we could use for other experiments. In terms of other releases, probably our biggest chunk went out as larvae or as larvae that were either loose or inoculated into stems. So I'll speak about this method a little bit later, but you can see that pictured in the bottom middle there. So each of these are cut Phragmites stems that have 3 larvae of one of the species manually inoculated into them, and they're stuck in florist foam to keep that stem moist. We can put blocks of those out. Larvae will eat for a while, chew their way out, and make their way into the patch. So this is one of the main ways we've been putting larvae out so far, and this was used at 3 different sites. We also took those pupae in part that we had from our rearing experiment and put them out at a number of different locations. At 4 of them along a latitudinal gradient, we essentially put pupae out in open containers, sort of as a quick method, with the idea that the pupae moths would emerge, mate, lay eggs in the patch, and establish a population. We also attempted a release using pupae that were put into an enclosed space, basically a 6-foot by 6-foot by 6-foot cage, to try and keep them contained as a different approach to doing this. So if we take a step backwards, 2021 was again the first year we really had this substantial wave of releases. In total, we released across 7 locations. So on the map, we're looking at in yellow, those would be our pupal release sites, in blue, larvae. We've released approximately a total of 1,800 eggs, 1,600 loose larvae, that's basically just dumping them into the patch, 2,500 larvae inoculated into stems, 270 pupae, and in the end, 6 moths, which are really just pupae that emerged early, so they went out as moths instead, totaling about 6,200 insects. So in this year, the emphasis has really been on testing these different release methods to see what works well. And the timing with which we do that. And I'll speak more to that a little bit later. So monitoring...
Just to interrupt you for a second, is there any way that you could not use your headset? We can hear you, but it's just a little bit choppy. I'm just wondering if we can make it a little clearer.
Sure, it's using the computer mic for a second here, not a headset.
Okay.
Sorry, we had some internet issues here earlier, so this is a bit of a suboptimal setup. Let me try something a little bit different. Here, just give me 10 seconds. I'll be right back.
Okay, thanks so much.
Well, while we're waiting, if anyone has any questions they're thinking for Michael, they can put into the question and answer section. So at the end of this presentation, he can answer them for us.
Okay, how's that? Are we doing any better?
That's very clear. Thank you so much. Sorry
Okay.
about that.
No, not a problem. Now let's see if we can get that back. We're still sharing the PDF there?
Yep, I can still see it. We can't see you anymore, but otherwise, yep, you're getting lots of thumbs up. It's great.
Perfect. Thank you very much for putting up with that. Okay, let's jump back in. So after these releases, one of the things we really want to focus on is monitoring, of course. And because we were able to do releases this year, we were able to do some insect monitoring as well and figuring out how to do that. What that looks like, when do you do it, and so on. So as an example, I'm going to use some of our sites where we used our emerging product protocol for how we monitor after releasing these stem inoculated larvae. So there are those blocks of stems, again, that are put out in these blocks of florist foam. These typically go out in the 1st to 2nd week of May. And what we're trying to do there is hit a certain phenological window with the frag stems when they're about 30 to 60 centimeters tall. So these would go out then. As a next step, one of the nice things about this release method is that these stems, you can come back and recollect them a couple of weeks later. At this point, the larvae have chewed their way out, made their way into frag in the population, and they leave behind these tiny little pinprick holes when they exited. So this is something that we can actually use to quantify how many larvae maybe went into the patch. So you come back mid-May, and are able to take a look at that. The next step that we've been working on developing is to look for stem damage. And what we've been seeing is a really good time to do this is sort of mid-June. This is a point where the larvae have been feeding for a while. There's some damage on the plant, but the vegetation has not overgrown to the point that it's impossible to see it. And then sort of the next step from there that we're still working on, but that seems to work fairly well, is to come back kind of mid-fall, maybe mid-October, and this time to monitor focused a little bit more on impacts to the plant itself in terms of, for example, stem density, panicle development, height, and so on. So from this 2021 monitoring, to keep in mind, this is very early. These are insects that went out just this past spring. We're really looking just to see if they've made it into the patch at all and have started to do some feeding. But of course, one of the best things that we would want to be able to see are the insects themselves. So if we go into some of those stems, for example, and crack them open, we are indeed, we have been able to find some of those larvae. So this is, for example, a later instar Lenisa geminipuncta larvae found inside one of the stems in the field. And it's really good evidence that they're able to start that life cycle in the field on their own, which is really great to see. Now, we are, of course, trying to establish populations, so we try to do as little of this direct disturbance as possible. So more often, we're looking at indirect measures. So some of the things that we can look for, as I already mentioned, those emergence holes. If we're releasing as stems, that's a really easy measure that we can get. Other things that we're looking for in the midsummer there and in the fall would be the larval boreholes. So as they complete their life cycle, they will exit stems and make their way into several stems before they complete their development. And they will leave behind these boreholes that, especially when they're larger, can be fairly distinctive. So we're able to quantify those as well. This feeding can cause stem wilt and stem damage. Another thing that can happen, especially on larger, older stems, is that when that main growing tip is disturbed, you will get the development of smaller secondary branches. So when we see this kind of branching combined with a borehole like this, this is really a distinctive thing that we can look for in the field. Stem wilt and death, we've been seeing this as well. One thing I've discovered is that it's extremely difficult to capture in a photograph, but both of these do show examples of stems that you see one of those boreholes is marked there, and then above that point where they've been feeding, the plant starts to die off. So you get sort of this browning and this wilting occurring. So we've been really encouraged to see this initial larval feeding and the damage that's happening to the plant. This is a fantastic start, but there are some caveats to it that we really want to keep in mind. And the first is how early this is. One of the key periods that we're going to be looking for is whether they are able to complete overwintering and establish longer term. So when we go back next year to monitor, one of the big questions will be, Were they able to lay eggs and mate and make it through the winter and start a new generation? Beyond that, of course, we need to continue to assess for long-term persistence of the population, so looking from that second year onwards. And then when we really start to look for population level impacts, which is what we're trying to achieve here, those will also take time. So that's more of a longer term sort of year or two and onward kind of thing that we'll be looking for. But again, this initial larval feeding is a really great start. So a few key lessons I wanted to pull out from this work so far. One of the big ones has been that we've seen release timing really matters quite a bit. So what we're trying to do here is align the phenology of the plant with the development of the insect. If we're releasing as larvae, one of the things I mentioned is we're trying to hit that sort of 30 to 60 centimeter tall stem window, and they only stay in that state for a certain period of time. So what we've seen is when we release in sites that are close to that target, we see quite a bit more feeding than we do at sites where we've been forced to, just because of logistics, release later. We see less. We've also seen from the very beginning in 2020 that predation of different life stages, be that eggs, larvae, or maybe even pupae, could be a limiting factor as well, as it is often for insect populations. So we're exploring different tools that will offer some amount of protection. That can also include timing, so making sure that material is not out for longer than it needs to be to relieve some of that predation risk. As I mentioned, we're also learning how key monitoring windows, there are better and worse times to be looking for different kinds of damage. So we're trying to develop a protocol for what that looks like. And a lot of this has to do with the state of the frag and other vegetation around it. And finally, one of our big focuses has been on the release methods. And what we're seeing so far is that these stem larval releases really work quite well, but they're also very labor intensive. So these photos here give you a breakdown of more of what that process looks like. Essentially, you have hundreds or thousands of these tiny eggs that hatch out into hundreds to thousands of these tiny larvae. And of course, as soon as you open that dish, they're all over the lab unless you try and really contain them. And then you're manually inoculating a few into a stem at a time. So it works really well, but it also takes a lot of effort. So we're exploring other options as well going ahead with next year. So that ties into a quick look at some of the upcoming work that we're building towards here. Looking at 2022, of course, throughout, always what we're going to be doing is lots of monitoring. So monitoring of everything that we've done to date, looking for that overwintering, looking for that longer term population establishment and impact. We're going to be focusing again on eggs this coming year. So looking at releasing as eggs, which has a lot of advantages to it, and exploring different timings for the eggs. So one of the things we're comparing is what happens if you put out eggs to overwinter on a site compared to eggs that go out basically in the spring, fairly last minute. And we have a new apparatus that we're testing to try that out at 3 of our different sites. So they've already got their batch of overwintering eggs, and we'll be going back in the spring to supplement that with more as well. We're also very excited to be starting up a new large-scale release site, which will be focused more on insect impact on vegetation, how vegetation changes in response to biocontrol agents, and dispersal. So we're excited to be working with Rebecca Rooney and her group out of University of Waterloo on this. As we've heard, they have a lot of experience with this kind of work. So we're really excited about this partnership. And this is something we're going to be applying at replicate sites in future years as we go forward as well.
2 minutes left. 2 minutes left.
Great, thanks. We've got 2 different agents as well. So we also want to be doing a release to compare how they behave, what kind of damage occurs. So that'll be an additional release this year. And we'll also be doing more rearing to produce additional pupae, moths, eggs for rearing and for other experimental releases. Looking forward, of course, monitoring is always ongoing, and there will be an increasing emphasis on what the impact to the vegetation is over several years. And as we get more and more of these key methods refined and what works the best, what we're really looking to do is scale up. So our capacity for insect release, insect rearing, and then release on the landscape. So to conclude, this is again a biocontrol project that's been in development for over 20 years. And it's a really exciting time. As of this last year, we now have multiple releases going on in Ontario, which is really great. As a reminder, biocontrol does take time. And so a lot of this is about long-term monitoring and looking for long-term trends. But we're also very encouraged about the initial insect feeding that we've seen. It's a great start. So we're going to keep an eye on that going forward. And as we do so, again, lots of monitoring, continuing to refine these methods. and really building towards an increase in the scale of what we're able to rear and release across an increasingly large scale on the landscape. And of course, all that work to date and coming up has been supported by our many collaborators in this project who we greatly appreciate having on board for this. So thank you very much.